In this section, we'll handle Graceful Shutdown. In the user package, we'll mimic a database disconnect or some other service cleanup, and then we'll shut down the server gracefully as well. Our server's looking pretty good, as long as it's running, but there is one main thing that we're missing here. Currently, when we close the program, everything just drops, and you can see here it was interrupted by SIGINT. This isn't actually a problem for this program really, but in a real implementation, we'd be dropping whatever our data source connection is. That could be something like a connection to a database or to another service that's still expecting us to be here. It'd be ideal if we were to go ahead and clean that up before we quit. In order to imitate a function like this, let's go ahead and go back to the users. And we can just collapse this all down. We just need to add a shutdown, and we'll have it wait for a couple seconds to simulate some operations that are underway. We'll make a method off of manager called shutdown. It doesn't need any arguments, and it doesn't need to return anything for our purposes. We'll slog info to say that we're shutting down, and then we'll sleep for 2 seconds. And then we'll slog to indicate the shutdown is complete. That's all we should need for this part. Let's go back to main. We don't really need to add testing for this because, for one, this method isn't actually doing anything special. And for two, anything we're shutting down here would be more the responsibility of the thing that we're connected to ensure works correctly. We don't really want to write test code that exercises code that we didn't write and don't own. Back in main, let's make a little room here. We want to make sure that this is shut down no matter how this program exits. Ideally with our graceful shutdown, but in the case of a crash or something like that, we want to make sure that the last thing we do is ensure that our user manager gets shut down. For this, we can use defer. With that done, let's turn our attention to shutting down our server gracefully. Right now, as you can see, we don't really have a way to get a hold of this server that's listening and serving because it's using the default. What we want is to be able to call shutdown on the HTTP server instance. In order to do that, we'll need to create a new instance of an HTTP server using primarily defaults, but substituting in our address and mux. We do that this way. And let's go ahead and make sure we move our mux up above it. And then we would be able to, instead of using the default here, substitute in the server we just created. And that should work the same way it has been up until now. But there's a problem with this. Once we're in here, we're waiting until listen and serve returns, which it never does unless there's an error or unless we stop. For this, we need to create a go routine to launch the server. And we can create one just like that. It would also be helpful for us to know that we're starting the server. So let's go ahead and add that. We'll just use slog. And instead of log.fatal here, let's actually capture the error. We're doing this because we're going to call close on this. Note here, after server.shutdown or server.close, the returned error is error server closed. We have a sentinel error here that we can use to determine whether or not there was an issue. So here we can say if the error is not equal to nil, and not errors.is error server closed, then let's slog with an error. And then do os exit with a 1. A non-zero exit code conventionally indicates there was a problem. Now let's run this. As you can see, the Go routine fired off, but then the program exited, and our user manager shut itself down. This is not exactly what we want, but that's okay, we can fix that too. This gets a little bit complicated here, but first, let's go ahead and create a wait group. And then we'll add one to the wait group. And we'll add that because of this function we're about to write. Here, we're going to defer wait group done. And just so we don't forget, let's go ahead and put our parens at the end there. Now we need to listen to the OS signals, and we can do that with a channel. And don't worry if you're not exactly sure what's going on here, just follow along and we'll get there. We're going to make a channel that takes an os.signal. And here we're going to use signal.notify. You can see here that signal.notify causes the signal package to relay incoming signals to the channel we specify. When we add signals to the argument list here, that indicates that only these signals will be relayed to the channel. Now, we'll say that we're going to receive on the signal channel. This will block until something is received on this channel. You can do non-blocking I/O on channels in Go, but that's beyond the scope of this course. For our purposes, we can wait for this. It's in a Go routine. Once the signal is received, we'll slog info to say that we are shutting down. And then we need to actually do our shutdown. For this, we're going to need context. And a cancel. And we'll do a context with timeout. This will be a child of context.background. And we'll say that our timeout is 10 seconds. We want to give this a little bit of time, because if there are requests in progress, the server should try to finish them before it shuts down. We want to add defer here to say that no matter what happens, when we leave this function, we need to call cancel on this context. And now we need to call shutdown. We're going to capture the error if there is one and check it. And for this, we'll just slog it if it does exist. Now, if we were to run this right now, the program would still immediately end because we fired these off into Go routines and they're running asynchronously, and then we reach the end of the main program. That's why we use the wait group. Here, we can wait for the wait group to be done. And if you notice up here, we've deferred two things. First, we deferred shutdown cancel, which will be executed, and then we've deferred wait group done, so that no matter how this Go routine ends, our wait group gets released. Here, we'll just log info that the server shutdown is complete. Now, let's run our server again. You can see here we still get our starting server message, and if we stop, we can see that we're shutting down the server. Server shutdown is complete, and then our user manager shuts down as well. Everything has been tidied up, and our resources have been released. Let's go ahead and make sure that we run this once more, and let's open up our API testing tool. Let's add a user, since none exist. We've got a 200 OK. Let's change to get user. We'll take this line out. And you can see it echoes back our response, so our server's still working. And then we have a clean shutdown. Just like so. And that will complete this tutorial. Congratulations on making it this far. I really appreciate your time and effort in completing this. There are some resources that I can leave you with. Not the least of which is this great article by Matt Ryer. He's been working at Grafana for quite some time. You can see here that he covers things like a new server constructor, long argument lists, different places to put things. I actually stole his Graceful Shutdown method because I liked it a lot better than the ways I've done it before. This is a great read. You don't have to do everything exactly the same way he does, but it's worth considering. And I'll leave a link to this in the description below. Now for the challenge. Go out and make your own project. Do something interesting, and then feel free to share it on social media and tag me. You can find my information also in the description. Thanks again for watching, and good luck.